So today's lesson we're going to be reviewing factoring, and the thing about factoring that's interesting is that there's so many different possibilities depending on what type of polynomial or quadratic or any type of equation that you have. There's so many different things to consider, and I like to think of factoring in terms of 4 different methods and really kind of stick to those. So I'm going to go through briefly each of them to kind of show you the procedure, the process, the way to think through each of these kinds of problems that'll be beneficial to helping you be successful. Whenever you're factoring a polynomial, you always want to start with greatest common factor as that method. And essentially what you're doing with greatest common factor is just what it says. You're finding the greatest common factor of all the terms, and then you're going to basically reduce it down. I like to think of it as distributive property backwards. I think it's easiest if we look at a problem first and then kind of walk you through those steps. The bottom line is, anytime you have a factoring situation, you need to check greatest common factor first before you try any other method. So we'll start with a problem like this. You've got 28n to the 4th plus 16n to the 3rd minus 80n. Now when you're finding the greatest common factor, you can approach this a couple different ways. One, you can just look at the terms and go, alright, what's the biggest number that goes into each of the other numbers? That's one way to approach it. The other way to approach it is actually break all the terms down and try to figure it out that way. So I'm going to do that, and that way, if you need to do this, you know how to do it. If you don't need to do it, you don't need to. So this is 28 is 4 times 7. 7 is prime, so I'm going to break this down one more time. 2 times 2 times 7. I do the same thing with 16, which is 4 times 4, which is 2 times 2 times 2 times 2. And then for 80, let's go 8 and 10. So this is 4 times 2, so that's 2 times 2 times 2. And then 10 is 2 times 5. And then all you've got to do is go, okay, what do they all have in common? And I see they each have a 2. And they each have another 2. I think that's it. So even though 16 and 80 still have more 2's, 28 we've used up all the 2's. So here's what this means. It means that the greatest common factor is 4. Now we're talking about between the coefficients because that's 2 times 2. So this is 2 times 2 that they all have in common, which means a 4 goes into all of those other numbers, and that's the biggest number. And then because when I look at the variables, you look at n to the 4th, n to the 3rd, n to the 2nd. The part that becomes the greatest common factor is the term with the smallest power. So the greatest common factor here is going to be 4n squared. And again, hopefully this is a review and you've seen this before. Now, and actually to do the factoring, what we do is we take 4n squared, and again, this is where that reverse distributive property comes in. And I take 28n to the 4th and divide it by the greatest common factor. And then I take the next term, 16n to the 3rd, and divide it by the greatest common factor. And then I take the last term, oops, that should be a minus, because it's a minus 80, 80n squared divided by the greatest common factor, and then I simplify. And so my final answer is 4n squared. Okay, 28 divided by 4 is 7. N to the 4th divided by n squared is n squared. Then plus 16 divided by 4 is 4. N to the 3rd divided by n squared is n. And then the last term, 80 divided by 4 is 20. And n squareds cancel out. So I'm done. So that is factoring using the greatest common factor. If you notice here, what's left in the parentheses is a quadratic expression, and we're going to be factoring that further. soon, but I want to make sure that you understand how to do greatest common factor. Greatest common factor, as a review, you can use on any polynomial. Doesn't matter how many terms there are. There can be 2 terms, 3 terms, 8 terms. You should look for greatest common factor in any kind of polynomial. And again, it's just like distributive property backwards. The next